Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 10D. Myself is Rita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GS Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of this conference is being held in a hybrid mode. The physical event was held day before yesterday in Pune, India, and the virtual event is being held through Zoom from the 19th till the 21st of January 2026. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Professor B. Umeshwari, who is an assistant professor in the Department of Computer Science and Engineering at JCRC Jaipur, Rajasthan. She has over 14 years of experience and 2 years of technical expertise. Her skill set spans C, C++, Java, J2EE, .NET, and RPA technologies, with numerous certifications including in machine learning and network security. She has published over 20 plus research papers and co-authored a book on operating systems, as well as has 2 patents to her name. We welcome you, ma'am. I'd like to begin with our papers. First presenter of the day, we have Sandeep Y. Babade with the paper titled A Taxonomy and Review of Score-Level Ensemble Fusion Approaches for IoT Botnet Detection. So if you're ready, then you may start with the presentation. It seems we do not have him in the meeting yet. We'll proceed on with our next presenter. Show Jakhon with the paper titled Artificial Intelligence as a Transformative Driver of Digital Innovation, a Structured Review and Impact Analysis. So if you're ready, then you may start with the presentation. Next presenter, Midhun with the paper titled Classification of Perovskite Crystal Systems from Elemental Features Using Machine Learning. So if you're ready, then you may start with the presentation.
Yes, ma'am. Ma'am, can you see my screen?
Yes, sir, it is visible.
So, good morning, everyone. Today, I am going to present my topic: classification of perovskite crystal system from elemental features using machine learning. So, these are the contents I am going to discuss in the upcoming sections. So, let us start by introducing what are perovskites. Perovskites are the compounds having chemical formula of AbX3, where A and B are metallic cations and X is an anion. Oxide perovskite have oxygen as the excite anion. So this is a schematic diagram of an AbO3 unit cell. Here, A cation is at the corner, B cation is at the body center, and the oxygen anions are at the face centers of the unit cell. Oxide perovskites are highly stable and compositionally more versatile. This makes them important for various applications, particularly in optoelectronics, piezoelectrics, and ferroelectrics. Now we can talk about the importance of the crystal system in perovskites. Cubic is the ideal perovskite symmetry, but real structures usually distort into other crystal structures. Structural symmetry directly controls the properties like dielectric response, conductivity, band gap, optical behavior, mechanical properties, etc. This brings us to our motivation of this study. Determination of crystal system is essential for predicting material properties and application. Experimental methods like X-ray diffraction, neutron diffraction are accurate but time consuming and resource intensive. There are alternative methods like mathematical estimation methods using density functional theory, which are computationally expensive for large amount of data. Here comes the importance of machine learning. It enables a rapid and scalable prediction after training and help accelerate high throughput material screening. The objective of this study is to build a machine learning model to classify AbO3 perovskite into respective crystal systems by using elemental features and engineered crystal chemistry descriptors. Then classify and compare 12 different machine learning algorithms, identify the best performing classifier and identify the top most influential features which determines the crystal structure of a oxide perovskite. There have been many previous work done on this topic. I'm going to talk about some prominent ones. Behra and team classified 675 oxide perovskite using machine learning, where light GBM performed best with 80.3 prediction accuracy. And they identified key structural descriptors which affect the stability of perovskite. Their methodology included data cleaning and feature filtering, then implementing a stratified cross-validation pipeline with machine learning classification using three models: light GBM, random forest, and support vector machine. The descriptors used by them were elemental and structural features of A site, B site, and oxygen. Another work was done by Priyadarshini and team where they compared 7 machine learning models for oxide perovskite structure classification, where XGBoost classifier achieved the highest accuracy of 84%. They implemented oversampling techniques like SMART analysis combined with feature selection methods for improved performance. Their methodology included pre-processing using chi-square and Spearman selection, then using a stratified k-fold cross-validation on machine learning classification using models like k nearest neighbors, support vector machine, decision tree, light GBM, and XGBoost. They also used descriptors like elemental and structural features of A, B, and O site. So our methodology was inspired by these two works, and our first step was to generate a data set. So 6,417 oxide perovskite samples were collected from the material project repository, and each entry included A site and B site descriptors. These descriptors included 25 elemental features of both cations like ionic radii, electronegativity, etc. And on the top of that, there were 12 additional engineered features derived from various elemental properties. The samples were distributed into 7 different crystal systems like cubic, orthorhombic, trigonal, tetragonal, monoclinic, hexagonal, and triclinic. So after generating the data set, the next step was to filter the data set. The purpose of filtering was to remove samples that cannot form stable perovskite structures. For filtering the data set, geometric stability factors like tolerance factor and octahedral factor were used as physical constraints. So the perovskite samples having tolerance factor in the range 0.82 and 1.1 and octahedral factor in the range 0.414 and 0.732 were kept, and the samples outside this range were removed. The reason is that the perovskite samples lying outside this range were geometrically unstable. The removed compositions are not geometrically stable, so our retained data set only contains 1,711 stable compositions. The dataset had another issue, the existence of polymorphs. So polymorphs are compounds existing in different crystal structure but having same chemical formula. Since the descriptors only depend on the constituent elements, these polymorphs share identical descriptors. So this makes the classification a multi-labeled classification, which is difficult to implement without compromising the performance of the model. So these perovskites are entirely removed from the dataset. So after removal, only unique structure entries are retained, and dataset is reduced to 905 composition. And 4 dominant classes like cubic, orthorhombic, trigonal, and tetragonal are left in the dataset. So the next step in the methodology was feature reduction. Out of the 37 features in the data set, many of them were strongly dependent on each other. So these features add only little information for the machine learning model to work. So correlation analysis was used to identify redundant features, and one feature out of a pair with the absolute correlation greater than 0.85 is removed. So this reduces redundancy and multi-collinearity and increases the interpretability of the model and prevents overfitting. So after removing correlated features, the final feature count is 25. So next step was to balance the data set. The current data set was heavily imbalanced across the classes. As we can see on this figure, here cubic and orthorhombic are the dominant classes and trigonal and tetragonal are minority classes with very few samples in it. So this will uh, cause the machine learning classifiers to naturally bias towards the dominant class. So to overcome this, we need to balance these classes. An oversampling technique called SMART is used to balance the classes. So SMART basically generates new synthetic data points for the minority classes and oversample them to match with the dominant class cubic. So this resulting data set was used for a machine learning model. So these are the machine learning models used for classification. These include logistic regression, naive Bayes, k nearest neighbors, decision tree, random forest, extra trees, XGBoost, light GBM, support vector machine, neural network, ADA boost, and gradient boosting. So machine learning model training was implemented using a five-fold cross-validation process. These are the evaluation metrics which are used to analyze the performance of the machine learning model. So these are recall, precision, accuracy, and F1 score. So these metrics are defined based on a table called confusion metrics. So confusion metrics have four cells, each containing number of true positive, false negative, and true negatives in a binary classification process. Out of these four evaluation metrics, F1 score is used as the primary evaluation metrics due to its ability to work with the imbalanced data sets. So after implementing machine learning model training, these are the
Thank you,
results
sir.
of the
I'm really
classification.
sorry to interrupt you, but I'd like to remind you of the time limit.
Okay.
Yeah.
So here are the results of the classification. Here the 12 different machine learning models are evaluated using 5 different evaluation metrics. Here F1 score is the primary metrics and models are arranged in the descending order of F1 score. This is a graphical representation of the above results in the terms of F1 score and ROC. In the descending order from left to right, here extra trees is the best performing model with an F1 score, highest F1 score, and random forest coming second. So after finding the topmost machine learning models, then we implemented a sharp analysis pipeline to identify the topmost influential features determining the crystal structure of a perovskite. And this is the sharp analysis results of extra tree classifier. And these are the top 10 most influential features determining the crystal structure of a perovskite. These are the observation based on the result. Extra trees emerged as the best classifier with F1 score 0.9098 and accuracy of 91%, which is better than previous studies. It gave the best performance due to its ability to capture nonlinear trends. Thermal steric stability and bonding related features influence crystal structure the most. Engineered features significantly improve performance. Ensemble models work best for crystal structure prediction, but the minority classes still remain a challenge. The conclusion of the study is machine learning can rapidly classify perovskite crystal structures. Elemental features combined with engineered features offer strong predictive power. Extra trees provide most balanced performance. ML is a scalable alternative for conventional methods for initial and large scale screening. So our study doesn't end here. This study can be extended for future works like to implement all classification in 7 crystal systems. This can be developed into a multi-label model to handle polymorphs. The study can be extended to include halide, nitride, and chalcogenide perovskite. We can explore graph neural networks like CGCN and MagNet to incorporate structural features. It can be extended to implement a hybrid machine learning DFT active learning framework for iterative improvement. So by this, I am concluding my presentation. Thank you.
Good morning, ma'am. Am I audible?
Yes, ma'am, you're audible.
Okay. Sir, can you tell me the data set you have used and data collection period for your
Yes, ma'am. Ma'am, the data set was sourced from from material project repository. We fetched the data using their own API. So, the data set generation process, the time
how
period was
pre-processing you have done for your data?
yes, ma'am.
How you have done, sir?
Ma'am, we used previous literature for the pre-processing.
Pre
Like previous studies, the samples were
no,
removed
whatever
based
data
on
set
their
you have taken, you would have done pre-processing for the data set, right? How you have done the pre-processing for your data set?
okay, ma'am.
Okay,
Like
thank you.
first, hello, ma'am.
Huh.
Yes, ma'am. First, we removed the like there were two properties like octahedral factor and tolerance factors. So based on that, we removed the samples which are geometrically not stable, and we also removed samples with the missing values, and then we removed duplicates from the table. Then we removed the polymorphs having different crystal system but same chemical composition. Then the main issue was the class imbalance. Then we balanced the data set using uh, applying oversampling technique. That's how we created the final data set.
Okay.
This was the
Okay, sir.
pre-process.
Thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding ahead with our next presenter. I'd like to call upon our next presenter, Nam Hoang, with the paper title Consumers' Continuance Intention to Use Fintech Services, the Role of Technological Adaptation and Innovativeness. Sir, if you're ready, then you may start with the presentation.
Yes, ma'am.
Yeah.
May I present may I share my presentation?
Yes, sir. Please go ahead.
So, let me start. Greetings to all professors and researchers. My name is Trần from Ho Chi Minh University of Banking. Today, I would like to present my research on the topic Consumers' Continuous Intention to Use Fintech Services. The research focused on explaining what motivates users to continue using fintech long-term, a topic that is increasingly important in the context of Vietnam's effort to promote the digital economy. Vietnam's fintech sector is experiencing.
Sir, your slide is not moving.
Pardon? Oh, wait for me. Okay. Vietnam's fintech sector is experiencing rapid growth, fueled by young, tech-savvy population and strong government support for cashless economy. Leading platforms like Momo and Zalopay dominate the market. However, challenges remain, including regulatory uncertainty, cybersecurity risks, and infrastructure limitations. Despite this, the sector shows resilience and continues to attract both domestic and foreign investment, indicating a promising future for digital financial services in Vietnam. While much research has explored initial adoption of fintech, fewer studies address what drives users to continue using these services. Existing models often ignore the role of technology adaptation, a key behavioral mechanism. Moreover, there is a lack of integrated frameworks that combine environmentally and stimuli user conditions and system quality. This study addresses these gaps by integrating stimulus, organism response, information system success model, and adaptive structuration theory to better explain continuous intention. The stimulus organism response model explains how external stimuli like system quality influence internal states such as satisfaction and adaptation, which then drive behavior. Information system success model provides the quality dimensions, system, information, and service that serve as stimuli. Adaptive structuration theory as a behavioral lens, emphasizing how users actively adapt technology into their routines. Together, these theories offer a comprehensive view of how users engage with fintech over time. The proposed model integrates three theoretical frameworks to examine continuous intention. It includes 11 hypotheses. Quality dimensions influence adaptation and satisfaction. These in turn affect continuous intention. Perceived technology innovativeness moderates the effect of adaptation and satisfaction on continuance. This comprehensive model captures both system attributes and user condition in explain certain fintech usage. The study used a mixed methods approach. A focused group of 10 fintech users helped refine measurement scale. Then a survey collected 267 valid responses from users in Ho Chi Minh City. Partial list where structural equation modeling was used to test the model due to its suitability for complex models and moderate sample size. The measurement model showed strong reliability and validity. On construct had grown but unfair above 0.72 and the average variance extracted about 0.5. Discriminant variety was confirmed using the IGFT criterion. 3 items with low outer loadings were removed to improve model fit. These results confirm that the measurement scales are robust and appropriate for further analysis. The structural model supported most hypotheses. Adaptation had a strongest direct effect on continuous intention, followed by satisfaction. Interestingly, perceived innovativeness strengthened the satisfaction continuance link, but weakened the relationship between adaptation and continuance. The findings highlight the dual role of innovativeness and the central importance of adaptation in sustaining fintech usage. The finding emphasize that user adaptation and satisfaction are critical for continuance. System and service quality has stronger effects than information quality, suggesting that users expect accurate information as a baseline. Innovativeness plays a complex role. It enhances the effect of satisfaction but reduces the impact of adaptation, possibly due to higher expectations among tech-savvy users. This study contributes theoretically by validating adaptation as a key mechanism in post-adoption behavior. Practically, it suggests that fintech providers should focus on intuitive onboarding and tailor innovation strategies to different user segments. Future research could explore adaptive saturation and the role of personalization in sustaining long-term engagement. I finished my presentation. Thanks for your listening.
Sir, can you mention some of the hypotheses you have used?
Pardon?
Hypothesis you have used, can you mention? Okay, thank you.
Thank you, sir. We'll be proceeding ahead with our next presenter. I'd like to call upon presenter Barwan N with the paper title Defender AI, Diagnosis of Legal and Government Assistance Chatbot. Sir, if you're ready, then you may start your presentation.
Yeah, hello everyone. I'm going to present my topic regarding diagnosis of legal and the government assistant chatbot, which we call it as a defender AI to defend crime and protect the victims. So let's begin with the problem and the reality. And the woman and the individuals are facing social and legal or informational barriers, continue to face harassment.
Yes, ma'am. Ma'am, I
Uh,
believe sir disconnected because of a network issue.
Okay,
Yeah.
we can go for next one so that if
Okay,
he
okay.
joins, we take.
Okay. So we have our next presenter. Bandla Muri Charan Sir Sivasai with the paper titled Eco Wallet Scheduler Renewable Aware Container Deployment Using Carbon Credits. So if you're ready, then you may start with the presentation.
Good morning, ma'am.
Yeah. Good morning, sir.
Ma'am, is my screen visible?
Yes, sir, it is visible.
Let me see. Can you see it, ma'am? Hello.
You can start, sir.
Yeah. Yes, ma'am. Good morning, ma'am. And our project title is Eco Wallet Scheduler Renewable Aware Container Deployment Using Carbon Credits, ma'am. And we are from Amrita Vishwadyapeetham, Bangalore. Like before going into the presentation, I would likely to be brief about the concept of green computing. Like green computing refers to the environmentally responsible and sustainable use of computing sources. Also, it focuses on reducing energy consumption, minimizing carbon emissions, and also improving efficiency across the entire life cycle of computing systems, from data centers and networks to software and application. As we can see in this today's world, cloud computing plays a major role in global energy consumption. Therefore, also integrating sustainability into cloud infrastructure is essential. Our projects aligns directly with the principles of green computing by making cloud scheduling decisions carbon aware, renewable aware, and user accountable. As we can see, our main aim is to uh, main aim of the project is to design and develop an eco-wallet scheduler that enables renewable available container deployment using carbon credits, also promoting sustainable cloud computing through carbon efficient job scheduling and user driven eco incentives. Also, our objectives are like to introduce a carbon wallet system for tracking user level carbon credits, and also to develop a renewable aware job scheduler, then to implement a carbon credit marketplace, also add gamification through a green score leaderboard, and also enable credit loan and recovery mechanism and also to integrate predictive wallet management for informed decision making. Then we can see the introduction. Like cloud computing plays a vital role in today's digital ecosystem, supporting applications like from web servers to large scale data processing. And also like the we can see rapid growth of cloud data centers has led to a significant increase in energy consumption and carbon emissions. The environmental impact of these data centers largely depends on whether they are powered renewable or fossil based energy sources. Also, most exciting cloud schedulers focus primarily on performance and cost optimization, while largely ignoring the carbon footprint of job execution. Like as a result, workload may run on high emission nodes even when renewable powered alternatives are available. And also, this highlights the to address the challenge. Our project EcoWallet Scheduler introduces a renewable aware carbon credit system container based scheduling framework. By integrating carbon wallets and renewable energy awareness into scheduling decisions, the system encourages users to adopt eco-friendly uses while maintaining performing and flexibility. These are the papers which we have seen used in them. Like from our literature survey, we have observed that like most existing schedulers are energy aware but not carbon aware. Also, user level carbon accountability is largely absent. Then like we can see some incentive mechanisms to promote sustainable behavior are minimal. Also, the limitations is in existing approaches motivated the design of a carbon credit based scheduling model. These are the 12 papers which we have used for our references, ma'am. And
Okay, methodology you can go with.
our novelty is like the key novelty of our project is introducing a carbon credit economical model into cloud scheduling, enabling user level carbon credits, carbon wallets, selecting nodes based on renewable energy percentage, integrating gamification and predictive recommendations. Like this transforms sustainability from a back-end concern into a user-driven and measurable process. Like the methodology, ma'am. Firstly, we can see into renewable aware node selections. Like um, the scheduler evaluates available compute nodes based on real-time renewable energy percentage. Like there are three execution modes: eco mode, which is highly renewable nodes, which is belongs to 80%; normal mode, medium renewable nodes, 40%; and also high performance mode, which is low renewable nodes, 10%. Like the carbon credits for each job is calculated using this formula, ma'am, credit cost calculation. And this will ensure that greener nodes consume fewer credits and encouraging renewable utilization. The algorithm which we have used is like renewable aware carbon credit scheduling algorithm. Each node is assigned a renewable energy percentage where jobs are scheduled on nodes with maximum renewable availability and minimum carbon cost. Also, user wallet balance and green core are updated automatically after execution. Then we can track historical job patterns and energy trends. Also, we can predict future wallet depletion, and we can give some proactive recommendations such as scheduling at optimal times will give some more credits, some and also we can what time you need to which mode to get more credits. And another algorithm is like carbon credit economic algorithm. This algorithm mainly manages the economic backbone of the system by regulating credit consumption during job execution, rewarding eco mode jobs with bonus credits, enabling credit purchase through a marketplace, supporting temporary credit loans with recovery mechanisms, and all the transactions are monitored and updated in the real time, ma'am. Then this is the block diagram which I have used. And this is the system architecture, ma'am. Like backend we have implemented using Python Flask with a modular blueprint architecture, and front end we have developed using HTML, CSS, and JavaScript. Also, we have used some SQLite database used for persistent storage. Then chat.js used for real-time visualizations of wallet and leaderboard analytics. Like we'll get some graphs and all, pie chart, all of that. Also, this application is containers used Docker for portability and deployment. We can see the results. Like this is the home dashboard of our main website. Like we can see carbon wallet, how many credits he's carrying, and what is the green score, and we can see some predictive suggestions like your wallet, like that. And we can see the recent jobs which he have performed using which node and which at what cost and other timestamp. And this is how we can submit the job. We can select the user and job name and what kind of work should be done. Then we can upload the file which we need to the work should be done, and we can select the mode. Like if it is eco mode, it will take more time and less cost. Then normal mode, it will take medium time, medium cost, and node C, which will take like high cost, and also it will take less time. Then we can see here, we can see like how to buy the credits. We can select the user who want to buy credits, and the amount is like it per one credit it will take 8.33 rupees, and for 30 credits it took 249. And we can see payment methods here. And also this is one of the user we have performed to show you guys like how many jobs you have performed, how many total credits you have, and
Can you
also
mention the real-time application of your project?
one second. Like we can have some green cloud data centers, also some enterprise cloud platforms. smart cities.
Are you doing any comparisons? How it is improving the system?
Like by comparing with traditional cloud schedulers, we they mainly focus on performance, cost, and resource utilization without considering carbon emissions, man. And we have added a carbon awareness by scheduling based on renewable energy percentage and
Uh, in your graph, have you ever tried to show with the existing systems? What
no,
is
no,
the no? What
no,
is the
man.
sharp difference between yours and the existing, like traditional cloud systems?
No.
Okay. What is the future scope of yours?
Like the future scope is machine learning driven scheduling. Like we can incorporate a AI based prediction models for further optimizing credit cost, node selection, and workload forecasting. Also, we can integrate with live renewable energy data sources. Adopt also we can adopt with machine learning based scheduling models. And we are trying to extend this to large scale multi cloud environments, man.
Mm.
And also we are trying to implement a mobile and cross platform deployment.
Okay. Thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding ahead with the next paper presenter. I'd like to call upon paper presenter Shantam with the paper title Mapping the Intersection of AI, FinTech, and Renewable Energy, a bibliometric analysis to identify research gaps. Sir, if you're ready, then you may start with the presentation.
Hello.
Yeah.
Good morning, ma'am.
Good morning, sir.
Am I audible?
Yes, sir, you're audible.
Okay. Can I have the permission to share the screen? Okay,
Yeah,
I
sir,
have
please
it.
go ahead. Please go ahead.
Thank you. Hello. Good morning, everyone. So I'll be presenting my work or our work titled Mapping the Intersection of Artificial Intelligence, FinTech, and Renewable Energy. It is basically a bibliometric analysis to identify the research gaps. The study is motivated by the rapid growth of digital technologies and clean energy systems, especially in emerging economies like India. The focus of my talk will be to show where current research stands, where it is fragmented, and where the biggest opportunities lie. Over the last decade, we have seen explosive growth in three key domains, that is, artificial intelligence, financial technology or fintech, and renewable energy. AI is transforming decision making and forecasting. Fintech is reshaping financial access and investment mechanism, and renewable energy is central to global climate goals. However, while each of these fields has grown independently, their combined application is limited. There is no study which combines all the three, like AI, fintech, and renewable energy. There is a key research gap that fintech plus sustainability is rapidly growing. AI renewable energy is well explored. AI plus fintech plus renewable energy, that is rarely, very rare. And Indian focused integrated studies are minimal. Like I only got about two studies, and that too, it started from the year 2023. So the methodology that we used is simple bibliometric analysis using Scopus database. The time span was 2005 to mid 2024. The tool that I used for network visualization was WASPhere. Analysis we have done on the basis of trends, keywords, and collaboration. This is the search query that we used. Developed economies dominate interdisciplinary research, but India has papers in individual domains. Like we have paper of AI fintech or AI renewable, but very few integrated studies related to AI fintech and renewable energy. The key network analysis that we've gone through using keyword co-occurrence analysis in WASPhere, we identified four major clusters. As you can see, there are four major clusters: the red one, the blue one, the green one, and the yellow one. And here, fintech is acting as an enabler. India performs well in individual areas such as AI applications, but The four major thematic clusters shows that fintech appears as a connecting bridge, but not as a core integrator with AI and renewable energy simultaneously. Sustainability emerges as the central theme linking all clusters, but true interdisciplinary integration remains weak. So the key findings that we got from here, overall, our findings show that the research landscape is highly fragmented. Fintech enables sustainability, AI improves technical performance, but investment risk modeling using AI for renewable energy financing is largely missing. And this gap is especially important for India, as India has set a target of 500 gigawatts of renewable energy by 2030. So there is still some future direction of like integration of AI, fintech, and RE is a research frontier. Indian focused empirical studies could help India to get to its goal. And in the very future work, we can enable or we can include explainable AI, policy risk, and green finance tools together to develop a framework that can predict where we have to invest, what are the risks, what are the opportunities. These are some of the references that I've used. Thank you.
Can you suggest any framework from your side?
Like, ma'am, actually I'm a PhD scholar, so this is basically the starter. Like, I have to first identify the gaps.
Okay.
So now, what I am working on is that I am currently working on a paper that is basically AI versus traditional risk models, comparing the traditional risk models to evaluate the energy investment risk in India.
Okay, sir. Thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. We'll be proceeding ahead with the next presenter. I'd like to call upon Ria Angira with the paper titled Resource Constraint Fine Tuning of Large Language Models Comparative Analysis for Educational NLP Data. Ma'am, if you're ready, then you may start with the presentation. Ma'am Ria? Ma'am Ria?
Ma'am, she's dropping a message, network issue.
Yeah, okay. We'll proceed on to the next presenter. Till then, you can join in, give your presentation afterwards. So we have our next presenter, Joshini KS, with a paper titled Traffic Fingerprinting of Encrypted IoT Protocols and Privacy Mitigations. Ma'am, if you're ready, then you may start with the presentation. Ma'am Joshini? It seems she's not here. So if Ma'am Ria, you're ready, then you may start ahead, or Sir Barvin, if you haven't presented yet.
Hello, ma'am.
Yeah, sir, you can continue your presentation.
Okay, ma'am. Thank you.
Yeah.
Hello, everyone. I'm Bevin, and my co-authors are Ajita E and Anbu Chelones. So, I worked on a topic regarding diagnosis of legal and the government assistance chatbot, which we call it as a Defender AI.
Sir, share your PPT first.
1 second. Is it visible, ma'am?
Yes, sir, it
Yeah.
is visible.
Okay, thank you. So, hi everyone. Myself Bevin and my co-authors are Ajitai and Anbu Solinas. So, we have worked on the topic regarding diagnosis of legal and government assistance chatbot, which we call it as Defender AI, to defend crimes and protect the victims. So, the problem and the reality. The women and the individuals are facing social and legal or information barriers, continue to face harassments and safety issues globally. So nearly 30 to 50% of the genuine cases remain unreported, and even among reported cases, many victims fail to obtain their justice timely. And the key reasons behind it is fear and emotional trauma, and the lack of legal awareness, dependency on the others, no immediate support system. And this leads to offenders roam freely due to the silence and the fear. So the core challenge, psychological challenges we have figured out is the fear. Victims are often in a fear, anger, and emotional shock. In high stress situation, the people commonly can't able to logically think, clearly explain what was happened, and decision making. So before getting justice or moving to the apply any cases, the psychological stability is very important. So the gap in existing system is the existing system is only focusing on legal procedures or documents and the formal process. They ignoring emotional state, fear, and psychological readiness. No system support victims from distress to the justice. So our core idea, Defend AI is completely AI-based digital companion, which is designed to support emotionally, psychologically, legally, and we follow the flow which is emotional distress. We will be moving make them to stress bus, and after that we'll move to the make them confidence to apply complaint against what was happened to them, and finally we'll make sure them to get justice. But our first priority is humans emotion before that legal steps. So the emotional stabilization. So the different AI will first, anyone is approaching a platform, they can't able to expose directly what was happened to them. They will be in a very high stress situation. They can't able to express it. So they will be saying, I was totally get depressed like that. They will be saying. So from that we can able to figure it out. They are in a high stress situation. So we will be psychologically calm them. So why we are calming is when anyone in a stress situation, they can't able to understand what they are trying to what we are trying to say, they can't able to understand it. So we will be make sure first calming them, and after the emotional stabilization we will gently ask what was happened and when it occurred. So like that story gathering, which in a very conversational manner. So, so if there is any immediate emergency is needed, we will guide them immediately. Go there and you use this service, government service to protect yourself. So the second, the third phase is after making them feel comfortable and gathering all those resources, we are ready to move on to the phase three, which is contains three. And the first one is the empowerment, the just bringing them to get motivated motivated and making them to file a complaint, because they have fear and lot of things which was holding back. We will be breakdowning it with you, what was happened to you is not acceptable, like that in a very psychological manner we will be saying. So this will build a confident, courage, and justice seeking mindset. So once it is ready, they will be in a very bold, and after that we will be giving the evidence guidance. So whatever the story they have given, and whatever the digital documents they have, we will be asking them, and we will be getting it. And parallelly, we will be, if there is any physical documents, we will be make sure them to take it with them and make it very structured. So the legal process clarity. So so where to file the complaint, and the police authorities how they will be handling. So the timelines in the sense, I will they will we will not say the entire time. We will be saying for the initial step, this much time it will take. So if it is exceeding the time, we will escalate the situation. So from this three phase, the they can able to remove the fear and builds the confidence because of the knowledge. So the legal filing and monitoring. We will be drafting complaint and preparing your users on what they need to do. After filling and applying everything, we will not stop there. After that, we will be tracking them. If there is any delays which was happened, we will be escalating it to the higher officials, because every petition or any issue, there will be a deadline. If government, the respective platform is not giving the response, between the timeline, we will be applying to the higher official. So due to this, the entire phase we will be traveling. So we will be in a very companion way. And the conclusion, thank you. The different area is not about AI. It is emotionally understanding the people psychologically and giving legal guidance. And we will be calming, confident, making them confident and informed. From the starting point of the issue to the ending point of the justice, we will be stay together. Thank you so much.
How emotional calming is done, sir?
Sir, ma'am, we will be using LLMs for it, and we will be using some architecture regarding that. We will be analyze, we will be figure outing using that. Each agents will perform each steps for emotional intelligence. We will be and getting the input from that. We will be analyze what type of emotional it is. According to this, if they are very clear, we will move to the next phase, psychology, the complaint applying guidelines, and like that, step by step, we will be doing, ma'am.
Your thing would work only for crime against women, or
No,
it
no,
will.
ma'am. It's commonly to every aspects, because uh, it can able to go beyond not only women safety,
How
for the
you
general
are
public in every sectors.
how you are communicating with legal authorities?
So basically, ma'am, legal authorities, we can able to create a data for related to legal things which are available over Supreme Court website. Using that, we can able to get all the laws, whatever the things needed necessary. We can able to take it from the website. We will be doing that
No. How
possibly
legal
by.
authorities will be connected with you, sir? And my question is.
Uh, we are self-sustained. We are planning to do it self-sustainedly, not relying on any legal teams. But when we are building it, we will be asking a lot of
If my
suggestions.
condition requires legal authorities, means that cannot be self-sustained, right? I need proper guidance to approach legal authorities. So, are you already trying to communicate with them, or you are in just?
Ma'am, we have already discussed with, especially I'm from Tamil Nadu, and in Kanyakumari district, inside Tamil Nadu, Kanyakumari district, we have attended a pitch with the Kanyakumari police, and we have just working on regarding that.
Okay, thank you.
Thank you.
Thank you, sir. Ma'am Ria, if you're ready, then you may start your presentation.
Am I audible?
Yes, ma'am, you're audible.
Okay, I'm sharing my screen.
Sure, ma'am.
Okay, so good morning, everyone. I am Ria Angira from Indira Gandhi Delhi Technical University for Women in Delhi. And today I'm going to present my paper titled Resource Constrained Fine-Tuning of Large Language Models, Comparative Analysis for Educational NLP Data. The title itself gives away the problem statement. And the plan of my presentation is introduction, background work, objective of the study, datasets, methodology, environment setup and implementation, results and discussion, conclusions, references. So recently, there have been many large language models like GPT-5, Llama, Mistral, Phi, Claude, Falcon, and they have set new benchmarks in a number of natural language processing applications. So, and they have shown a strong performance across a range of natural language understanding and generation tasks. But full fine-tuning of LLMs, whenever we increase the size or whenever we full fine-tune them, it is always computationally expensive and memory intensive. It takes a high amount of memory, which poses a problem in general for academicians and students. So parameter efficient fine-tuning techniques, methods, PEF methods, provide a practical alternative by updating only a small subset of model parameters and preserving most of the capabilities of the base model. These strategies drastically reduce the number of trainable parameters while preserving competitive performance by updating only a small subset of model parameters. So these are the PEF techniques, which will be the highlight of the study. LORA and QLORA, prefix, prompt, bitfit, and a few adapters. So LORA, in LORA, only so these are the techniques: LORA, QLORA, prefix, prompt, bitfit, and adapters. And in LORA, only a few rank matrices are inserted into the large language models, into the transformers layer, whereas in QLORA, it is quantized and mapped. So the size is drastically reduced. And we will see in detail in the further slides. So background work. Role of LLMs in NLP and education is highly significant. Their application in educational system enables automated tutoring, question generation and evaluation, interactive learning environments, etc. So their application is widely known. In education sector, it is being researched upon. However, full fine-tuning of LLMs, as we saw, is computationally expensive and limiting. So we saw the PEF methods, and especially in academic institutions or low resources environments, real-time educational platforms, this poses an issue. So education-focused NLP tasks often run in low resource environments and need for efficient fine-tuning alternatives. So what is the objective of the study? How do different PEF techniques behave across diverse educational NLP tasks under limited computational resources? There is a lack of systematic comparison was found across educational datasets, and that too under strict resource constraints. It is unclear which PEF method works best for which kind of educational tasks. Performance versus efficiency trade-offs are also unclear. So to perform a controlled comparison of the 5 PEF methods, LoRa, QLoRa, bitfit, prefix, prompt tuning. This is the objective. We will evaluate on education NLP dataset and analyze task performance, training stability, memory usage, and training time, and also provide key insights for a low resource setting. So these are the datasets collectively cover multiple educational task types, including multiple choice question answering, passage-based comprehension, and span extraction. Psych, race, and squad, these were the main datasets used. And Psych is a multiple choice question answering type of dataset. And race is a reading comprehension type of dataset. And squad is extractive QA. So these type of dataset, they highlight upon the different type of educational task. So we will derive 3 different insights for these 3 different type of educational tasks, and they are taken from Hugging Face dataset library. So the methodology we are going to follow is the mostly used, and data preprocessing, model loading, then PEF attachment, training, and evaluation. So the datasets are loaded and the raw data sets are tokenized and formatted according to the task type, and with a maximum sequence length to control the memory usage. We could not keep the maximum sequence length more than 512. So yes, and model loading. So the base model is loaded in full precision or in 4-bit quantized mode, depending upon the PEF strategy. So quantization was applied only during the model initialization for QLoRa experiments. And PEF attachment. So after the model is loaded, now the PEF, the fine tuning method is attached and to the frozen base model. So only designated parameters were marked as trainable. Training models were fine-tuned using supervised learning with task-appropriate loss functions. And finally, the evaluation was conducted according to the NLP task. So this is the diagrammatic view of the comparative analysis. After the evaluation, we will analyze the results and comparative analysis and the conclusion. So the environment setup, which included hardware and software.
And show me the result analysis, ma'am.
Yes, sure. So we can see the memory usage in this figure, the peak memory usage. We can see that QLoRa has the lowest memory, taken the lowest memory. And it is obvious because it is in quantized form and it takes the least memory footprint as it is mapped and highly compact. So this is the results for the psych dataset. We can see the 5 fine-tuning methods, and these are the number of trainable methods. This is the Rogel score, BERT score, and training time. So prefix method had this number of trainable parameters, and these are the scores which it scored after the evaluation, and training time was 0.508. And this graph shows the training loss curve, and these are the 5 fine-tuning techniques compared on a single graph. And so it illustrates the training loss trends for psych. Prefix and prompt show higher loss variance. So we can see that prefix and prompt show the higher variance, whereas the QLoRa and LoRa, they show a lower. And so these are the findings, and these suggest that similar task performance metrics do not imply equivalent system efficiency. So while LoRa and QLoRa, we can see that they gave the best and stronger task performance and training stability, but prefix and prompt provided a better trade-off between performance and efficiency under strict resource constraints, because number of trainable in a lesser number of trainable parameters, they scored a higher amount of evaluation metric score. Now for the race data set, we have so we have this loss curve here, and here also prefix and prompt have consistently higher loss values, but we can see the trend is going upper. Here it was going down, so we can say the training was successful. Here it was a bit unstable, so the curve goes up. And so this figure shows that the higher loss values are non-convergent curve with consistent oscillations, highly unstable training behavior. And and here is the table of the evaluation metrics, and these tables do not have the consistent scores as the psych dataset had, because so the lightweight prompt based techniques are insufficient to capture the complexity of such dataset. So we can say that psych dataset had a good evaluation metrics, whereas this dataset did not perform well for these 5 fine-tuning techniques, as the internal parameter adaptation becomes increasingly important as the task complexity and context length increases, because the race data set has high length of sequence. And for the squad data set, these are the
Excuse me,
findings.
ma'am. I'm really
Yes.
sorry, but I'd like to remind you of the time limit.
Okay.
Yeah.
Okay. So this is for the squad data set, and we can see that exact match was only for prefix, and none of the other fine-tuning scored the exact match. So this indicates that training and this training loss curve, this indicates that the training was stable and it is smoother. And the results highlight that tasks of extractive nature have the ability to influence attention patterns and the intermediate representations. So prefix injects continuous learnable prompts into each transformer layer. So
We'll
this
go to
helps in better,
conclusion now.
yes. So these are the conclusions. This work presents a systematic comparison of PEF techniques, and it has been observed that lightweight PEF approaches can still achieve meaningful performance on structured educational NLP tasks. Secondly, practical considerations such as memory usage and training stability are just as important as accuracy. Thirdly, the effectiveness of PEF method depends strongly on how well it matches the underlying tasks. These findings provide a more grounded view of how PEF methods have been in realistic educational NLP settings and may help guide future work where computational resources are limited. So, thank you. It's done from
You
my
have
side.
compared the parameters properly, but in educational field, how it is going to help the thing that you haven't explained.
Ma'am, in educational field, actually, when there are many kind of tasks which are performed, like we have selected the basic data set like psych, race, and squad. So
No, ma'am,
these
regarding
data
which domain you have taken, what exactly you are comparing. You have mentioned all the parameters, but what comparison you are doing there?
So I am comparing the fine-tuning techniques. Which
For
kind of
what?
technique is better for a particular type of task? So I have taken the basic level tasks such as psych and these question answer, science question answering, and the comprehensive type of data set. So these represent a particular type of NLP task. So they are the basic ones, and it can be built upon if there are complex type of tasks such as this automated tutoring or question generation. So if the tasks are complex, this can be built upon and used. So
Okay,
in a
thank you.
resource constrained environment, we can see which kind of PEF technique we need.
Okay, thank you.
Thank you, ma'am. I'd like to request Sir Gunjan Sonar to present their paper. So if you're ready, then you may go ahead. Sir Gunjan. It seems he's not available or has a network issue. I'd once again like to ask for Sir Sandeep, if you're here, or Sir Shoja Khan. We do not have them. Ma'am Joshini, if you're here, then you may start your presentation.
Hi, I'm Gunjan here. Due to some network issue, my
Okay.
PPT is not supported for that. So that's the reason. I'm just coming back with the 2 minutes.
Okay, sir. Till then, Ma'am Joshini, if you're ready, then you may start your presentation.
Yes, ma'am.
Yeah.
Good morning, respected chairs and dear participants. I'm Joshni from Amrita Vishwavidyapeetham, Bangalore, India. I'll be presenting my paper titled Traffic Fingerprinting of Encrypted IoT Protocols and Privacy Mitigations. As mentioned, my paper ID is 723, and my co-authors are Chandana Srinivasan, Gokul, and Ullas sir. Yeah, so our problem statement is that the IoT traffic exposes metadata that allow device behavior to be identified. So, although modern IoT systems rely on encryption to protect data, encryption alone does not fully guarantee privacy. So, even that's why we found out this, and like we have used even payloads are encrypted. Network metadata such as packet timing, size, and frequency remains visible. So these metadata patterns can be exploited to identify device behavior, leading to serious privacy risks. Our work focuses on analyzing this problem and studying how effectively such traffic can be fingerprinted despite encryption. So we have set the experimental setup in this work is that we have used MQTT over TCP protocol with TLC, which is commonly used protocol in IoT environments. So our experiment setup includes a RockPi device acting as an IoT sensor node, a PC running the Mosquito MQTT protocol, and a mobile hotspot providing a shared Wi-Fi network. We generated synthetic IoT traffic using Python-based MQTT scripts. The three different traffic behaviors were periodic traffic representing regular sensor updates, and bursty traffic representing event-driven communication, and attack traffic simulating abnormal high-rate message flow. And then the recap collection and the dataset preparation. All traffic was captured on the RockPi device using T-Sharp on the Wi-Fi interface. Since communication was encrypted, no payload data was accessible, and only packet level metadata was collected. We created a dataset around 15 pickup points with 5 captures for each traffic behavior as mentioned before. So each capture was labeled based on its traffic type and timestamp. To enhance the realism, and reduce overfitting, we introduced a background traffic noises such as like YouTube or Instagram streaming during data collection. Metadata feature extraction from the collected TCAP files, we extracted only metadata-based features. That is, these including time features such as the mean and standard deviation of inter-arrival times, size-based features like minimum, maximum, mean, and standard deviation of packet sizes, and also volume and protocol features such as total packet count, total bytes transferred, and MQTT specific packet counts. So these features form the basis of analyzing and fingerprinting encrypted IoT traffic. And the main part, that is the privacy mitigation strategy that they use. The main objective of our privacy mitigation is that to reduce traffic fingerprinting risk while maintaining analytical utility. So we applied multiple anonymization techniques, including IP address anonymization. We used SHA 256 hashing, MQTT topic anonymization through hash-based masking, and also port generalization into service level categories, and control timestamp randomization, which helped a lot for us as we have the less content dataset. And additionally, PCAP file names were anonymized using consistent hashed identifiers. This was done to avoid traceability. So after having done all this, we have also compared the traffic behavior before and after mitigation. After mitigation, we observed that traffic patterns become less distinguishable and behavioral signatures are partially obfuscated, means that so that there is no more pattern that you can recognize from the metadata or whatever the data that you have. So uh, as this has become less distinguishable, there are less chances that it will get violated. While fingerprinting is not entirely eliminated, the clarity of behavior interference is significantly reduced, indicating improved privacy protection. And here we also analyze the impact of mitigation on timing and packet services. Inter-arrival time is intentionally distorted in a controlled manner, and packet size distributions are altered to reduce predictability. These changes make it more difficult for an attacker to reliably infer traffic behavior while still perceiving the overall structure needed for analysis. And then privacy-aware feature regeneration. After anonymizing the details, a new data set was generated. We then applied the same feature extraction pipeline to this anonymized data set. And then statistical matrices were recalculated, and also the time patterns were recalculated to ensure consistency. This allowed us to study how mitigation affects ML-based classification. And then the ML machine learning models, we evaluated 4 models, SVM, random forest, XGBoost, and light GBM. The SVM achieved an accuracy of 100 with an ROC close to 100 again, and similarly random forest. And these results indicate that even after mitigation, metadata still carries strong behavior information. And you can see that SVM has overfitted because we had only collected 15 pickup files and the data set is very small. Whereas the light GBM exactly contrast to it has underperformed. Whereas random forest was strong and stable
Yes,
according
ma'am.
to the ROS. Yes,
I'm really
ma'am.
sorry to interrupt you, but I'd like to remind you of the time limit.
Yes, ma'am.
Yeah.
Thank you. And these are the curves that we got. This is for the SVM, and also that this is for random forest, and the other 2 are being added in the paper as well. So the challenges encountered are that during the initial stages of our study, we encountered several challenges like packet labeling, packet drops due to unsynchronized traffic generation and capture, and insufficient realism in background traffic. So to address all these issues, we recaptured all PCAP files as mentioned under synchronized conditions, introduced realistic background traffic, and ensured complete capture windows for all traffic classes. So to conclude, our study shows that encrypted IoT traffic can still be fingerprinted using metadata alone, while privacy-aware traffic manipulation reduces behavior interference. Encryption by itself is not sufficient to guarantee privacy in IoT networks. Additional mitigation strategies are necessary to strengthen the IoT privacy protection. So we have mentioned the future works as well. That is to add other IoT communication protocols and explore adapter and dynamic privacy mitigation techniques and evaluate the trade-off between privacy utility and system performance in real-world developments. Yeah. Thank you. Any more questions?
Can you mention any real-time application of your thing?
Yes, ma'am. So whether if a user is using any bank websites online, and you could and he or she has been using it frequently on that particular day and that particular time. So if the attackers could sense the pattern that on this particular time or this particular day he or she has been using it, and you could find a way to, even if it is and obviously banks are encrypted, and even if it is the attackers can use deploy it, they can actually like attack, and this is where you can use one.
Hello.
Yeah, sir.
Hello, may I audible? May I audible?
Yeah, yes, sir, you're audible.
Yeah. Basically, my topic is related to the analytics on study on green building material and yield rating. Basically, we are observing that today construction business is too much developing. Due to that there is a vast destruction of environmental issues. So that we are using a green building material and climate changing material to to build a buildings. For that we are taking to eliminate the issues. There is a two main framework of body regarding the lead and GRIHA. Lead, which is basically a global and a global a global entity, and while GRIHA is in India integrated habit of India in India perspective. So GRIHA in the India, GRIHA is a major role for setting a standards to green building materials ratings. So in this top research, we are basically comparing the lead and GRIHA, which is more suitable and which is easily with a lower cost and local quality materials with the Indian qualities for that. To the introduction, the green building materials have to reduce damage and support eco-friendly construction to make a building healthier and more energy efficient. So we know that
methodology.
Sorry,
methodology को explain कीजिए.
Yeah, I got it there for the methodology. The methodology we are taking for this the sustainable management. We are going to the sustainable management side and some energy, environment materials, and have some research on that, how they impact the environment and how it's suitable for the building material for the reducing the waste and increase the energy efficient buildings. So there is a rating system in I was already told that the GRIHA and the lead, which is two major entity, major framework body, which giving the ratings for the building materials, how it's a good or bad quality for the green building. So we have take some comparative studies and some hello, am I audible? Hello.
Yes, sir, audible.
Yeah. There is our main research objective is that to research various type of green building materials with the LEED certification to understand how LEED ratings that certifications to the building materials on this basis. Like we have FLASs and SC blocks, kind of low VOC paints, which we can use in the building materials so that the buildings can easily able to eco-friendly. Like we can see in this graph. This is a building which is based on the green building material. Like we have seen that they have wind energy, lime plasters, the rain harvesting things, then organic insulation, natural insulations, which giving the normal heat and protect from the sunlight to the building, and which reduce the less dust capturing and different type of materials, which is like we said roof lighting system and roofing products and kind of that. So we have also checked some materials, how its impact to reduce the damage and increase the environmental efficiency. Like we have used the bamboos for plastic lumber and natural stones, certificate block biobricks, which is used in the green materials to build a green material building, which is helpful to rise the sustainability and green energy resources in our developing countries like India, Bhutan, Nepal, kind of that. So we can also check here. There is a lead score which is comparable with a material and green material. Like example, a fly acid contact has a less embodied carbon, while lead which can be at the lead point for sustainability. And our study for this benefit of green materials to better indoor air quality, low energy bills, then stronger public image for because there is a low awareness regarding the green building in the recent trends. There is also low research published in the building materials, which can one of the major issues regarding regarding our study. So we have faced that kind of problems while we are researching on that green building materials, how we can increase the energy efficiency and reduce the wastage management. So basically a scope of work is to study economically and friendly making green building with fly acid, recycled steels, plastic, lumber, and bamboos, kind of that. So now we can look at how much energy and water and resources this material can save. Also understand the good points and problems using a green material in regional projects. The focus of Indian situation right now, the cost, availability and awareness, the cost is very high for the green building materials. That was a major issue, and availability of green materials and awareness is very low in the developing countries regarding the green building materials. So that is the big major issues we can rise with the lowering the cost of green building material and easily available, and make more aware about the green building material with this research. So this research help to increase the green building materials awareness and lowering the cost of green building materials. Hello.
Sir, what is your
Hello?
conclusion?
Yeah, I will go into conclusion now. Green building material is not simple fusion of green designing and techniques and materials. It is a holistic solution for the designing of designing and planning of buildings and construction to make a very effective and low cost effective and high high grade ingredient high grade green building materials. For that we just have to adapt it materials with a low cost. Like we have see that in the developing countries like USA, UK, Germany already developed their framework body to rating the system, like GBAS and GRAMS in Germany. They have taken 10 points allotted for the life cycle assessment of green building materials. Out of 10 rating stars, they will suggested that a 7 or 8 points for the green building material is very good. As we are saying in that research, so that is contents of a developing countries. There is already built a framework related to green building materials. But now in the developing countries, there is a lack awareness and too much cost for the green building materials. So there is a very minor usage of green building materials with the building structuring and planning. So that is rating agencies in India for the green building materials is a very few. So we have raised to awareness regarding the green building materials in the India for this research purpose. And that's it, ma'am, for the day. And there is some reference we have taking for the research purpose, like we are saying in the Indian green building materials IBC for a new construction reference we have taken for that. So there is also some references we have taken from the research paper. That's it. Thank you. Hello.
Okay, sir. Thank you for this.
Thank you, sir. Thank you, ma'am. I'd like to once again ask for Sir Sandeep and Sir Jakon. If you're ready, then you may start your presentation. It seems we do not have them in the meeting, so that brings us to the end of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I'd also like to thank our session chair for chairing this session. A token to the chair on behalf of team SmartCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you, ma'am.
Thank you, ma'am.
I'm truly grateful.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.